I did my case study on the Monongahela River main stem located in West Virginia. The Monongahela River main stem runs through Marion, Monongahela, and Taylor counties in West Virginia. It is located in the Monongahela River watershed. The Monongahela watershed is 7,340 square miles. The watershed includes 6 subbasins: Tigrit Valley, West Fork, Upper Monongahela, Cheat, Lower Monongahela, and the Euganey, all located on the map. Multiple streams are also located within these 6 basins. The Monongahela River watershed drainage and land use. For the drainage, it flows through the Pennsylvania to Pittsburgh, where it meets the Allegheny River to form the Ohio River. Cheat and Euganey are responsible for 72% of total drainage. The land use of the Monongahela River watershed is barren, cropland, forest, grassland, urban, residential, pasture, water, industrial, and commercial uses. The Monongahela River main stem has multiple uses. It is used as a habitat for fish, wildlife, livestock, and it is a water supply. It also has recreational uses, which includes fishing, kayaking, swimming, and boating. And it also has industrial and commercial uses, such as transportation and presence of industrial sites and brownfields. The water quality criteria for the Monongahela River main stem includes the pollutant fecal chloroform bacteria. It is a warm water fisheries, trout water, and human health contaminant. It shall not exceed 200 divided by 100 milliliters as a monthly mean, and no less than 5 samples can make up this average. Also, no more than 400 over 100 milliliters in the 10% of all samples taken should be present. The main stem of the Monongahela is 303 delisted. The Monongahela River is included on West Virginia's 2014 Section 30D list and draft and the 2016 Section 303D list. It is listed for a number of water quality criteria for fecal chloroform bacteria. The TMDL for the Monongahela River main stem. There were multiple TMDLs created for the watershed, but this was the first one for the actual main stem itself. And the causes of this TMDL were failing septic systems, discharges of untreated sewage, runoff from agricultural residential areas, and combined sewer overflows. In the TMDL, they used multiple data set and factors from other sources to actually create it. They took data from things like soil state, dam locations, road, populated places, and mine data. NPDES permitted sewage treatment plants were set at a permit limit 200 counts over 100 milliliters monthly geometric mean. All illicit discharges of human waste were reduced by 100% in the model. The methods used for this TMDL included general MDAS configuration, which involved subdividing the TMDL watershed into sub-watersheds and streams. Then multiple datasets were then used to create a model. Fecal chloroform configuration was also used, and it took into account runoff of urban agriculture, septic system, and sewage drainage. Model parameterization, allocation strategy, which used an in-depth equation to help develop the TMDL, gathering of weather data, and seasonal variation. Some recommendations for the future is to ensure that we have NPDES compliance, which this is the responsibility that the NPDES permits contains correct limitations set by the TMDL. Also, non-point source project monitoring. This should be done to monitor the water quality, and it is also used to determine future contaminants or pollution. And there's also TMDL, effectiveness monitoring, which this is the study in how well the TMDL that was put in place is doing over time. And this may take a lot of money and resources, but usually if the TMDL isn't effective, other plans are put in place. The health of the Monongahela River. Out of the 415 stream miles, 35 were fully supporting all uses, so that's about 9%. 22.63 were fully supporting all uses but threatened for at least one, that's about 5%. 356.92 were impaired for one or more uses, that's 86% of the stream was impaired for one or more of its uses. Metals were responsible for 246.72 miles of contamination. 219.7 miles was from an unknown cause, and 140.5 miles was from fecal chloroform. And the chart on the side shows some of the causes broke down in a pie chart. So the conclusion of this is the Monongahela River is heavily affected by industrialization and urbanization. It is affected by the coal mines that are in the area, urban runoff, and sewage treatment facilities, and also home septic systems. 50 streams in the 254 miles are on the 303D list. This concluding that the stream's health is not at its best moment right now, and there's a lot to be done to improve it back. The NPDES permits were given publicly and privately owned wastewater facilities within the watershed, 2 individually permitted POTWs discharge treated at 2 outlets. There are also 3 permitted stormwater discharges associated with the POTW, and 5 individually permitted non-POTW wastewater treatment plants. This table I made is for the Monongahela River main stem itself. The fecal chloroform bacteria is the only TMDL made so far for the main stem itself, and the monitoring plan for the bacteria is TMDL monitoring, so monitoring how well the TMDL is doing, non-point source project monitoring, NPDES compliance, and of course the limitation of 200 counts - 100 milliliters. There were some violations I found that have happened in the Monongahela watershed. One included a $177,000 for wetland violations, either from like urbanization or destruction of the wetland. There was also acid mine drainage violations, not just one, and as well as sewage drainage violations. And this is my works cited, and works cited continued.